Good morning, students. Good afternoon or good evening, whenever you're watching. Thank you for coming and joining us today. Today is going to be 2.16 chemical properties and chemical reactions. Today, again, I have my fifth period class who's helping me with the presentation. And Oscar, I believe, is going to be reading the introduction for us today. Go ahead, Oscar. Oscar. Okay, Irvin. Irvin, and who's going to help me? Hello? Is anybody out there? Yeah, Alexia, Irvin, Oscar. Okay, Oscar's having bad connection. What about Irvin or Yalexia or anybody else? Yalexia?
Yomen.
Okay, thank you.
It's not a good idea because the bicycle can soon begin to rust. You start to get a reddish orange building up of a rough deposit on the metal. It may start with a chain but can spread to the other parts of the bicycle, especially if there are scratches that create a bare metal surface. The formation of rust is a chemical process that takes place when iron is exposed to water and oxygen. It is estimated that damage due to rust costs U.S. businesses, military, and government over $276 billion a year, a very expensive chemical process.
Very, very, right? We have some very large cities like New York, Boston, Chicago that have been around for years, right? And some of the materials that some of these buildings were built with have begun to corrode or to rust, like they said. So obviously buildings have to be fixed or piping has to be fixed, right? If if there is a big pipe leak, downtown New York, they're probably going to shut down a big portion. And why are they going to shut it down? Well, because you have this large leak, and obviously you can usually shut down the water for just that building. But if it's a main supply, a main water line from the city, then they're probably going to have to shut down the block, right? And make sure that they fix the leak before they turn the water on, right? We don't want to be wasting good water on a leak. So we don't know. It also bridges, some of those bridges that were built in the early 18 or early late 1800s, early 1900s, have probably, if it's built with certain metals, will begin to rust. Okay, so we have to make sure that those bridges are safe and that any metals that have rust have been removed or cured of that rusting, uh the rusting process. Okay, because rust will begin to spread, right? It, like the bike, it said it may start off at the chain, but it can continue to rust other parts of the bike, right? And if you have a very expensive bike, do you really want to buy another one? And people in the city, that's one of the main sources of transportation, biking around the city. I have a friend who lives in New York who all she does is bike everywhere. She doesn't own a car. Why? Because first off, it's too expensive, especially parking in New York. You have to actually pay to rent a space to make sure that you have somewhere.
Yeah, yeah, se usa puro taxi, miss.
Yeah, that's why a lot of people in New York just use taxis. So, a bike is a lot easier and a lot cheaper mode of transportation to get across the city. So, you always want to take care of your bike. You never want to leave it out, especially in big cities, because just like her bike that she was using got stolen. So, we had to raise money to buy her a new bike. So, first topic is chemical properties. Now, just like you have a certain ability, you have an ability to run, jump, exercise all you want, especially Irvin. He says he runs every morning at 6 o'clock in the morning. That's how come he was sending me some assignments so early, because he gets up and he goes run. That's an ability. Elements have certain chemical abilities, okay? But if Irvin goes to run, it's not going to change who he is, okay? Awesome, Arlette. That's great. It's not going to change who Irvin is, but when it comes to elements, if it undergoes one of its chemical abilities, it will definitely change that element, okay? So let's talk about some abilities of chemicals and of substances. A chemical property of iron is that it's able to combine with oxygen and water to create this iron oxide. Okay, and iron oxide is the chemical name for rust. Okay, but in chemistry, we don't call it rust, we call it corrosion. Okay, and what corrosion means is that it's starting to break apart, whatever substance we're talking about. If you have a compound and it begins to corrode, it's beginning to break apart, to break down. That's what we mean, okay? Some other terms or examples of chemical changes. Anytime you burn wood, you are changing it chemically. If food begins to rot, it is changing on the chemical level. If a firework explodes, it has changed into something different. If a carcass, if an animal dies and begins to decompose, whatever substance that animal is made of begins to deteriorate. It begins to break down, which changes that compound completely. Fermenting. Fermenting is another example of substances turning or changing into something new. Okay, so anytime you ferment, that's like when you create like beer, you need certain substances that come together and ferment. Okay, and I don't know any specific examples, but fermenting is a process where
Miss Arlette dijo que no la escuchaba.
You can't hear me, Arlette?
Es que su microphone me se estaba escuchando raro, no se escuchaba bien.
Do I sound weird, guys? Can you hear me or no? Is it only Arlette or is it?
Yo la escucho, Miss, pero de repente como que se va la señal y la dejo de escuchar.
Okay, well, try your best, okay? That's all I can ask. Okay. Chemical properties are very useful in identifying substances. Unlike physical properties, chemical properties can only be observed when that substance is in a chemical reaction and changing into something new. Okay? A chemical change is also called a chemical reaction. So that process, if you have the ability to explode, like fireworks, once you have exploded, you have changed into something new. Chemical properties can only be observed in chemical reactions when that substance is changing into something new. A chemical reaction is a process where one or more substances has changed into a new substance. Example, zinc, and they have it here in picture A. This is an example of zinc. Zinc, it looks, before it reacts, it looks silver, gray. It can be grounded into a powder. Basically, you can smash it up and make this solid into a powder. Now, if you have zinc mixed at room temperature with sulfur, powdered sulfur, okay, which is a bright yellow element, and you can see it here in picture B, the result will simply be a mixture. So if you put these two together, you smash them both up and you put them together at room temperature, nothing's going to happen. It's just a mixture, right? Now, if you want a chemical reaction to occur, you're going to have to add some energy. And how are you going to add that energy? Basically, you're going to heat it up. You're going to put a little light underneath it, the Bunsen burner. You're going to put it on top, and it will chemically change into zinc sulfide. Okay, and you can see zinc sulfide over here in picture C. Now, though this picture that you see here looks very different than what it started with, right? It used to be silver gray, it used to be yellow, and look, it has become a white compound. Okay? That is completely, whatever I have here, this zinc oxide is completely different than what I had before. The properties of this zinc oxide or zinc sulfide is completely different than what it was before. It has undergone a chemical reaction. Here are some examples of elements from group number 1. Let's see what happens.
There are 6 alkali metals: lithium, sodium, potassium, rubidium, cesium, and francium. They're all soft metals which can be cut with a knife. In air, the elements quickly become coated with compounds that form on the metal's surface. Here, for example, is lithium. When we slice it, you can see the metallic luster, but the black coating quickly reappears. Sodium is kept under oil to prevent reaction with air. Again, when we cut it, the metal surface can be seen. But this time, corrosion occurs even more quickly. With the next alkali metal, potassium, the corrosion in air is so quick that it's hard to see the metallic luster at all. As we go down the group, the elements seem to react more quickly with air. Now let's see another reaction of the alkali metals, the reaction with water. We'll start with lithium. The metal floats on the water and reacts with it, giving off hydrogen gas. Now for sodium. The same sort of thing happens, although the reaction is a bit more vigorous. All the alkali metals react with water.
So they're going down the periodic table. First they started with lithium. Now they're going to sodium, which is in group 2, or in period 2 and period 3, I'm sorry. And then we're going to go further and look at the type of reaction. The lower you go, the more reactive the element is with water.
In the same way, let's see an equation for the reaction. Hydrogen gas is produced, and the metal dissolves to give an aqueous cation with a single positive charge. Now for potassium. This time you'll see a flame. The heat given out by the reaction is produced so quickly that the hydrogen gas catches fire. It burns with a lilac flame. The next element is rubidium. This time we put a safety screen between us and the reaction. You can see that things gradually become more terrifying as we go down the group. Let's try cesium, our 5th alkali metal.
So those are some interesting experiments that they were doing. All they were doing was mixing those metals with water. And you can see how at the beginning it was kind of okay, right? You could see that hydrogen gas being released. But the further and further you go down the periodic table, the more violent the reaction, the bigger the explosion, the more action you can say you see, right? All right, so we're done. In summary, a chemical property describes the ability of a substance to undergo a specific chemical change. So anytime that you have an ability to explode, the ability to corrode, the ability to rot, to decompose, you're going to change into a totally different substance. A chemical reaction is the actual process. The only time you can see that chemical property is during a chemical reaction when that substance is changing into something new. All right. Then you have your review questions, guys. You have 4 questions to do. What is a chemical property? Number 1. Number 2, what is a chemical reaction? Number 3, when can we observe a chemical property? And number 4, which I think is the easiest one, is freezing water a chemical property, guys? Do we change water when we freeze it? Or is it still water? I got ice in my cup. Did I change that ice chemically? Is it still water? All right. Thank you, 5th period, for helping.